Welcome, ladies and gentlemen. We are still in Packet 5, working through Activity 5.4 today, called Solving Problems with Perimeter and Area. We'll just get right to it. A pattern for a quilt patch is drawn on a coordinate plane, where each interval represents 1 inch. Parallelogram ABCD represents the patch. So Bryce is in charge of buying the ribbon that will be sewn around the outside of each patch. How many inches of ribbon are needed for each patch? So basically what they're doing, they're just trying to get you to look at a problem and be able to recognize what it is that you need from that problem. In this case, they are asking us the distance around this shape, which means we are going to be wanting to do some distance formula. So for those of you that might not remember, x2 minus x1 squared, quantity squared, plus the quantity y2 minus y1 squared, and then all the square root of all of that. So here we go. We're going to need some points first. Okay, to be able to do this, we need to do a couple distance formulas. A is at 1, 1. I'm going to go ahead and write these down here. A is at 1, 1. D is at 2, 8. And then we'll do B is at 7, negative 7. So there is a reason I only got 3 of these points, and I'll talk about it in a second, but for now we'll just do side AD. So that was the side, that was this top left side. It mirrors BC because this is a parallelogram up here. So here we go. Distance formula, so AD is equal to, and I'll go x1, y1, x2, y2. So 2 minus 1 squared plus 8 minus 1 squared. It's going to be the square root of 3 squared plus 7 squared. That is the square root of 9 plus 49, which is the square root of 58. So, in the last couple of videos I was using my calculator and I could not get it to turn, but today I did. Hooray! So we're doing the square root of 58, so you just go 58 and then hit the square root button. It'll pop out a number for you. So that is 7.62 for side AD. Okay. Now, because this is a parallelogram, I know that both sets of sides, both pairs of sides, are parallel. I also know that I can also tell that both these sides have the same length. I can do that a couple different ways, basically. So from AD, our slope is 1, 2, 3, 4, 5, 6, 7 up and 1 over. BC goes 1, 2, 3, 4, 5, 6, 7, 7 up and 1 over. So they both have the same exact distance that they're traveling. They both go up 7 over 1. Because they both travel that distance, we can just go ahead and say that for a perimeter, I'm going to have 2 sides with this length. So I have AD. I also have the side BC that has this length. So when we do calculate our perimeter, we'll use this value twice. So now for the other value that we need, I'm going to do AB right here. Up here. I'm going to do AB, and then again we'll double that one once we calculate this. So the measure of AB, and then this is actually also the measure of DC. Okay. So because I'm doing AB and I already have these labeled x1, y1, I'll go x2, y2 here. So 7 minus 1 squared plus negative 7 minus 1 squared. So that's going to be equal to 6 squared plus negative 8 squared, which is the square root of 36 plus 64, which is the square root of 100, which is equal to, and I don't need any calculator for this, 10. And yeah, there you go. So we have 2 sides with this side length 7.62 and 2 sides with side length 10. So we're going to go ahead and for our perimeter, we're going to go 7.62 plus 7.62 plus 10 plus 10. So that is going to be equal to, sorry, I was trying to do some mental math, but I could not quite do it. So 7.62 plus 7.62. So this is 15.54, and then plus 20 more is going to be 35.54 there. And this was in inches. Okay, so how many inches of ribbon are needed for each patch? So basically it was asking for the perimeter there, so there is our perimeter. Okay, so that was question 1. Now on to question 2. We go, Ada's bedroom is on the top floor of her house. In her room, the roof slants downward, creating 2 congruent trapezoid-shaped walls. One of the walls in her room is represented on the coordinate plane by quadrilateral ABCD. On each interval on the coordinate plane represents 1 foot. So as before they were 1 inch, now each square represents 1 foot. Ada and Marco are going to paint, sorry, I'm just down here now. Ada and Marco are going to paint the 2 walls and want to place a strip of painter's tape along each side of the wall so the paint does not touch any other wall, ceiling, or floor. What is the length of painter's tape to the nearest whole foot that Ada and Marco need to cover the edges of both walls? So similar to the last one, this is actually just going to be a perimeter problem. So perimeter, we're going to need some distance formula, at least for side AB here. But for sides AD, DC, and CB, okay, we can go ahead and just count squares on those ones. So DC, we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's side length 11. D, 4, 1, 2, 3, 4, or AD, excuse me, and then BC goes 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then we do need to calculate AB. So to do that, we'll need a couple points. So A is at point -5, -1, and B is at 6, 3. Okay, and then I want to close that off. So for measure of AB, I'll go ahead and label this x1, y1, x2, y2. We'll go 6 minus -5, quantity squared, plus 3 minus a -1, quantity squared. Okay. So this is 6 plus 5, 11 squared, plus 4 squared, 121 plus 16, square root of 137 there. So, sorry, I keep forgetting some of my little markings. I'm going back and doing those. I hope that if you look at all of this, it makes sense, and that is the goal here. So we'll go, I got my phone over here off the screen. 137, square root is 11.70, but we did say we would round to the nearest whole foot. So 11.7 would go ahead and round up to 12. Well, actually, sorry, we'll round up to the nearest whole foot for the entire perimeter. So for this, we'll leave unrounded right now, so 11.7. And then now I'll go ahead and add that with my other values. They are off the screen, but for our perimeter, we did have one side with 4, one side with 8, one side with 11, and our 11.7. This is going to be 12 plus 11, these two together, 23 plus 11.7 is going to, and this is kind of a way that I'll do it sometimes if I don't want to use a calculator to add it in my head. So now 23 plus 11.7 is going to be 34.7, which rounded to the nearest whole foot is going to be 35 feet, and that is all for our perimeter. And this is kind of this is a way that I'll do adding if I don't have a calculator. Obviously I did, but I don't know, sometimes I think it's faster. Instead of digging your phone out of your pocket, you can just do it really fast. So there you go, that was question 2. So now question 3. Question 3, we're still talking about the same wall. Okay, Marco says he can draw a diagonal to divide trapezoid ABCD into a right and isosceles triangle to determine the area of the trapezoid. Ada says she can draw a horizontal line segment to divide trapezoid ABCD into a rectangle and a right triangle. Who's correct? Explain your reasoning. Well, if we look at our shape, so one of them says that they can draw a diagonal and make an isosceles triangle and a right triangle. The other one says that they can draw a straight line to create a rectangle and a right triangle. So when I look at this, the way that I would imagine this trapezoid is with a dotted line right across here, which is what the second person was talking about, and this would create a rectangle with a right triangle, as we can see. Okay, the diagonal one might be a little harder to see, but it is possible. So if you go from A and you do a diagonal, sorry that I go shaky cam, I'm doing the dotted line, and it's kind of shaking my desk that I'm doing this on. Okay, so here, so you see if I do this diagonal, it would create, if I cover up this, okay, it would create an isosceles triangle there, and then what's left over is a right triangle. So it would indeed, both of them actually are correct. You can't do that both ways. So who's correct? Explain your reasoning. For this one, you can go ahead and say both are correct. And then you can draw the figures. You can talk about how you constructed those two lines. Either way is great, okay? But that is how you can do those. You can those two constructions to get a rectangle and a right triangle, and then to get a right triangle and an isosceles triangle. So now on to question 4. 1 gallon of paint covers approximately 400 square feet. So I'm just going to go ahead, 1 gallon, 400 square feet. Sometimes I'll do this on word problems. It just helps me to keep my info as I'm reading it. So 1 gallon of paint covers approximately 400 square feet. Boom, 1 gallon, 400 square feet. Ada estimates she has about 1/4 of a gallon of paint. So 1/4 of a gallon, 1/4 of a gallon would be approximately 100 square feet, right? Boom. 1/4 of a gallon of paint remaining of color she wants to use. Does she have enough paint for both walls? Explain your reasoning. So for this one, this is an area question. So it's saying she wants to paint both of her walls with 100 square feet of paint left, and she wants to paint both of them, and she's asking, or basically we're asking if we can do that. And actually, I totally forgot. Okay, so I totally forgot. So actually, this one, sorry, hopping back to number 2, this just made me remember. Hopping back to number 2, we did want to know how much tape was needed to cover the edges of both walls. And so what we found was the perimeter of one of these walls. So our final answer, perimeter for both walls, would actually be this multiplied by 2. So our final answer here would actually be 70 feet. Sorry about hopping around like that. I just remembered because on this problem we're actually talking about both walls as well. And so I just wanted to make sure. So this would be, this one would be our final answer here, 70 feet. And again, that's because we needed to do the edges of both walls, and this was for one wall, and so 70 feet would be for 2 walls. Okay, so now back to this one. So she has 100 square feet of paint that she wants to use, and we want to figure out if she can do that, okay? So basically we said that we broke our shape up into 2 different shapes. Personally, I liked doing the rectangle. So bringing back our shape here. I think it's easier to do this rectangle and then this right triangle, because instead of calculating the area of 2 triangles, I can do the area of a rectangle and the area of 1 right triangle, which for me I just think is a little easier. So so now I'm actually going to draw this line because we're doing this, okay? For this top right triangle, our base is 11, so base is 11, and our height is 4. And then for this rectangle, we have a 4 by 11, okay? So that means that for our wall, we have 2 areas that we're adding. This is a composite figure. Remember, we're working with complex figures that we can add together, or that we can put figures together. And we're trying to find the area of that. So the area of the rectangle, here, I'm just gonna get rid of that. Area of the rectangle, we said was 4 by 11. So 4 times 11, and it is 44 square feet. And there, okay, so that's the area of the rectangle, and then the area of the triangle with it was, we said the base was 11, so it's going to be 1/2 times 11 times 4, 1/2 base times height. So this is going to be 11 over 2 times 4, which, I'm going off the screen here, my bad. Okay, which is going to be 11 over 2 times 4, which is going to be 44 over 2, which is equal to 22. So square feet. And one wall was both of these shapes together, so that means that the area of one wall is 66 square feet. Okay, and then because we have 2 walls, we multiply that by 2, get 132 square feet. And so, I mean, it says that she has about a quarter left, so if you wanted to argue how big of a difference that about makes, you could say that maybe, just maybe, she could paint it, but we're going to go ahead and assume that her quarter of a gallon that she has left is more exact, and that leaves her with 100 square feet. And so the square footage of both walls is 132. So does she have enough to paint both walls? We would go ahead and say no, 32 square feet short. And then you can just compare these two, right? This is how much she had, this is what she needed. So cool. So that was number 4. Okay, now we are on, so this is the beginning of 5 and 6. We'll use these numbers. And really fast, there is a typo on this one. I will tell you guys in class as well. So this gazebo goes up to 0.16, and then all of these numbers are like they are, okay? And then this goes to 0, negative 17. And so if you look, this y-axis goes by 2's, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16. This line would be negative 18, okay? But it says negative 17. So just for, yeah, so this is, we're going to go ahead and correct that, go negative 18 here. Okay, so, and I'll tell you guys in class as well, it's just something to note. Okay, so it says Emma and Kevin are designing a gazebo for the local park. The polygon shown on the coordinate plane represents the base of the gazebo. Each interval on the coordinate plane represents 2 feet. So each of these squares, instead of being 1 foot like the previous problem, are going to be 2 feet. So it says the base of the gazebo needs to be built with lengths of lumber around the outside. Oh, sorry. Keep going off the screen. Okay, it says the base of the gazebo needs to be built with lengths of lumber around the outside to support the floorboards. What is the length of lumber needed for the outside of the base? Okay, so the first thing I'm going to do is just count the sides that I can that are vertical or horizontal. There's 2 sides in this case that are vertical. So this one is right in the middle of a square. So that means that every half that I go, every 1 square that I go up is going to be measured by half here. So I go up 1, 2, 3, 4, 5, 6, 7, 8, and then a half. So I went up 8.5 squares times 2 is going to be 17. And then these lines over here, if you were to draw a straight line, actually correspond. So that means that this side is also going to be 17. Okay. Now we have to do a couple distance formulas on this one. I'm just going to do them over here. Okay. We actually only need to do two, because, and the reason we can do that, if you can see, we have some symmetry. So if I were to draw a line straight across here and then divide the shape like this, you can see that these 2 triangles are the same. And so because they have an equal base, or let's go ahead and count just so I can prove it to you, okay? So these are 1, 2, 3, 4, 5, 6, 7.5 squares. And then from here, 1, 2, 3, 4, 5, 6, 7.5 squares. So because both of these triangles have the same base and the same height, their hypotenuse, or side C, if we're talking about right triangles, A, B, C, both of their sides C are going to be equal. So if I find the length of side AB here, I will also have this side length of AF. Similarly, on the bottom, if I were to draw straight across here, and this one's not on a grid line, so I apologize for my not perfectly straight line, we can see that the base of this would be 1, 2, 3, 4, 5, 6, 7.5, and then 1, 2, 3, 4, 5, 6, 7.5. Okay, so again, so these both have the same base, same height. Now, one thing that we have to notice, okay, from negative 9, this y value, to negative 18 is a difference of 9. The difference from 8 to 16 is not 9, okay? So we do need to be a little bit careful, because side AB will not be the same as side CD, but AB will be the same as AF, and CD will be the same as DE. So I'm just going to do side AB over here. And to do that, I need a couple points. So A is at 0, 16, and it's actually, I don't need to label them, they're already right there for me. So I'm going to go x1, y1 for A, and x2, y2 over here. Okay, so here we go. So we're going to go negative 15 minus 0 plus 8 minus 16. Okay, so that means that I'm going to have negative 15 squared plus negative 8 squared. So now on my calculator really fast, I don't know what 15 squared is off the top of my head. I should, because I'm a math teacher. 225? Yeah. Okay, so 225 plus 64. I'm just doing some stuff over on my calculator right here, which is the square root of 289. And then the square root of 289 is 17. Oh, didn't know that. That's a fun one. Okay, so that's equal to 17. So that means that this side length is 17, this side length is 17. Okay, and so now, I don't know if they wanted this shape to be a perfect hexagon. If they had made this a 16 instead of a 17, it would be a perfect hexagon. A hexagon being a shape with 6 sides. But I don't know. Here we go. So now we want to do measure of CD. So CD, for this one, I'll go x1, y1, x2, y2. Okay, so I'll have 0 minus negative 15, and then I'll have plus negative 18 minus negative 9. So I'll have 15 squared plus negative 9 squared, which is going to be 225 plus 81. And sorry, we're still square rooting all that. And of course my phone just went away, so we go 225 plus 81, 306, and then the square root of that is going to be 17.49. I'm just going to go ahead and say 17.5. So that means that both of these sides are 17.5. Okay. And just really fast note, using symmetry to solve these problems is actually a very good strategy. So it saves yourself some work too, right? Like instead of having to find the area or the length for 6 sides, excuse me, it allows me to just do distance formula on 2 of them, and then using what I know about horizontal and vertical lines on the grid line, it allows me to just count this one and then double it. So it literally cuts your work in half. So don't be afraid to do that. So now I'm just going to add all of those up. I had 4 sides. With length 17. So I'm going to go ahead and do all those. 4 sides with length 17 plus my 2 sides with 17.5, and that would be times 2. So 17.5 times 2 is 35, and 17 times 4 is 68. Add those together, we have 90, 103. And so when I sound like I'm babbling to myself like that, the reason I do it is I add my tens first. So 60 and 30 is 90, 5 and 8 is 13, 90 and 13 is 103. So that would be our perimeter here. That would be the lumber, okay, that is needed. So number 6, how many square feet or floorboards are needed for the base of the gazebo? Describe how you determine your answer and show your work. Okay, so I already actually broke up the shape when I was talking about symmetry. So I have a big gigantic rectangle right here, and then I have some 2 small triangles and 2 small triangles. And so again, because of symmetry, I can calculate this triangle, double it to get that triangle as well, get this triangle, double it to get that triangle, and then just do all that one gigantic rectangle, okay? So I'm going to do this. I'm going to have 3 things. I'm going to have area, rectangle. Okay, I'm going to have area, top, tries for top triangles, and then area for bot triangles, and then we'll add all those together at the end. So the area of this rectangle, okay, this is 17. And then when we were counting this, we actually already counted it across. We said it was 7.5 for the base and then 7.5, which is 15 more. So that means it's a 17 by 15. Oh shoot, and actually, so I need to be careful. So it was 15 across, but remember each of these squares is 2 in length, so it would be 30 here. So we need to be 30 times 17 for the area of our big rectangle. For the top triangles, we had a base of 7.5, which is 15, and then we have a height of 1, 2, 3, 4, which is 8. So that means I'm going to have 1/2 times 15 times 8. And then for these bottom triangles, I'm still going to have 1/2, 15, but the height is different. We said that it's 18, so that's where this point is. So it would be 1, 2, 3, 4.5. So it'd be times 9, okay? So I'm going to do all of these calculations. 30 times 17 is 510, okay? 1/2 times 15 times 8 is going to be 60. And then remember there's 2 of those, so times 2 is going to be our total area that's in the shape up here is going to be 120. One of the triangles was 60, and then I multiplied it by 2 because there were 2 of them. So don't be confused. The area of the single triangle is 60, but then there were 2 of them. And then similarly here, I have this. Okay, so it's going to be 67.5 times 2 is going to be 135 for the area of both of the bottom triangles. So now for the area of the whole shape, I can just add all of these together. 510 plus 120 plus 135. I'm going to do my silly little thing again. So I got 630 plus 135. It's going to be 765 there for our area. And these are in square feet. Okay. And similarly up here, lengths of lumber. So it said, what is the length of lumber needed on the outside? Oh, this one didn't have units. So I guess it would be lengths of lumber. And I'm not sure if a length of lumber is a specific unit. Maybe we would have to divide this by something. Say a length of lumber is actually 3 feet. We might need to divide this by something. I do not know that, so I'm going to assume that a length of lumber is just 1 foot, and that this is 103 feet, so we would need 103, and then you could put lengths as the measurement there. Okay, cool. So now, number 7, we get into some really fun stuff here. Okay, so the graph, sorry, let me just fix my paper here. The graph shows the constant speed of a car on the highway over the course of 2.5 hours. Describe how you could calculate the distance the car traveled in 2.5 hours using what you know about area. Okay, well I know that the car is traveling 60 miles an hour, and it looks like it's traveling 60 miles an hour for 2.5 hours, right? So if I just asked you, just like we were just talking, having everyday conversation, and I said, hey, if I drive 60 miles an hour for 2.5 hours, how far did I travel? Okay, you would just take this 60, multiply it by 2.5, and then you'd get 120, 150. You'd get 150 miles that I traveled, right? And so the way that you're doing that is you're just multiplying. So the normal way we do this, we'd go 60 miles per hour times 2.5 hours. And I write it over 1 like this for a very specific reason, and we'll see that in the next problem, or not the next one, not here, but in problem 9. So it says describe how you could calculate the distance. So to describe it, you could just say, I guess I'm doing more work than I even need to right now. To describe it, you could say you can multiply miles per hour with hours traveled to get total miles traveled. Okay, so this one is just literally asking us to describe, so don't do too much work here, because question 8 says how far did the car travel in 2.5 hours? And then so using what we know about area, the reason that this relates to our area is because if you look at our shape up here, it has this 60 would be our height, and 2.5 hours would be our width, or our base and our height. And then this looks a lot like a rectangle, so multiplying these two things together gives me my area. And I actually already did it, I said it already. So our area of this rectangle is 150, so the area of this box that we have created by this graph is the area that we get here. So if you wanted to talk about that as well, how it's the area under this graph, you could talk about that as well. So how far did it travel? 150 miles. And again, that's just because we have 60 times 2.5, which is 150. Okay, so now it gives us a little info. It says the graph you used is called a velocity time graph. In a velocity time graph, the area under the curve, the line or curve, represents the distance. So that's kind of what I was talking about a little bit. The graph shows the graph shown describes the speed and the time of a passenger jet's ascent. So as a passenger jet is ascending, we have this little graph over here. How can you use the graph to determine the distance the jet has traveled in 25 minutes? So this question isn't asking us to do it. It's asking us how we could use that graph. So it kind of told us already. It says in a velocity time graph, the area under the line or curve gives the distance. So how can you do that? You could, you'd say you could find the area of, or you could find the area under the line. So you could find the area under the line. That's actually, I was going to say more, but I think that's all you need. You could find the area underneath this, okay? And then you could find your area there. Well, iPad storage, you know, it is what it is. So I am back right now. I did have to go delete some more videos. The iPad that Mouse Spokane gave me does not have a ton of storage, unfortunately, so I got cut off again. These long videos do take up a lot of room. So I was starting number 10. I talked about number 9 already, so here we go. I will just start over. So determine the distance the jet has traveled. So for number 9, we were looking at this graph, and we were trying to determine how far this jet has traveled. We just got done saying how the area underneath this will give us that time, or that distance traveled, okay? I think that this problem is a little backwards. It asks us to calculate how long it'll travel in 25 minutes, and then how long it'll travel in the first 5 minutes, but to be able to calculate how long it travels, how far it travels in 25 minutes, we need to know how far it travels in the first 5 minutes. So, Okay, I'm going to go ahead and do the first 5 minutes. I'm going to do part B first. And then after that, we'll just do the total thing together because I do think that this is an easier way to do it. So we said that the area underneath this, okay, is what we need to do, or what we need to look at. So we're just going to look at the area of this triangle to start. So one thing that we need to be careful about, okay, one thing that we need to be careful about is that the height of our triangle is 600, and that's miles per hour. Okay, and then the base of our triangle, and so I'm just reorienting it, it is the other way on our graph, is 5, but that is in minutes. Okay, so we need to be careful because on the last problem, we were traveling 60 miles an hour for 2.5 hours, boom, we just multiply it together, easy peasy, okay? But what we need to do here, we need to either translate miles per hour into miles per minute, or we need to translate this minutes into hours. So what I'm going to do, I'm going to go ahead and do minutes to hours. So I have 5 minutes over 1, okay? And this is what I was talking about on the last one. This is going to be useful here in a second, okay? And it might help you see how we change units times, okay? And I need to go 1 over 60, and that is hours over minutes. Okay, this is a little confusing, but hang with me, okay? So I'm saying that there is 1 hour every 60 minutes, which there's 60 minutes in an hour, so I've just changed it and flipped it, okay? And so now I have 1 hour and 60 minutes, which is still true, right? You can say it either way. I just basically did the reciprocal of that. So the way this works out, when we multiply fractions, so this is 5 over 1, when we multiply fractions, we just multiply straight across the top, straight across the bottom, okay? And so this is going to seem a little silly, but stay with me. So I have 5 minutes times 1 hour, okay? So I'm going to have 5 minute hours, whoa, okay, this is, now Mr. McGill, you're doing crazy stuff, okay, over 1 times 60, so 60 minutes, okay? So the thing that's nice about this though is that, so normally if I have a fraction, say I had like 5xy over 60x, okay, say minutes is x and hours is y, okay, I could cancel the x's here, get rid of those, and then I would just have 5y over 60, and I would do some simplifying and we'd be good to go, and you guys would be like, yeah, Mr. McGill, that's awesome, that's just algebra, we know how to do that. Okay, well, we can do the same thing here, we can cancel out our minutes. So now I have 5 hours, or 5 over 60, and this is hours over 1 for our unit now. So now I get to simplify this. So I have, sorry, I'm running out of room, or I'm kind of getting off the side here. So I have 1/12 hour over 1. So that makes sense that 5 minutes, so 5 is 1/12 of 60, so 5 minutes is 1/12 of an hour. And so if you can just look at that and just do it, boom, bam, you're good, okay? Some people, though, might have a hard time with conversions, so this is just one way to see it. I know in physics, seeing it like this helped me out a lot to be able to cancel those. And normally I wouldn't multiply it together like this. I just did it so you could see the whole thing. Normally I would just leave it in this form. Normally I would just leave it like this, and then just skip the part where I put them together and just cross out those minutes, and then I would just have 5 hours over 60, and then just go ahead and get to this 1/12 hour. Okay, so 5 minutes is 1/12 of an hour, and then so I'm traveling 600 miles per hour for 1/12 of an hour. So if I was traveling 600 miles an hour for 1 hour, I would multiply 6 by 1, and then that would give me, or excuse me, I'd multiply 600 by 1, and that would give me my distance traveled, which would be 600. So in the same fashion, I'm going to multiply 600 by my time, by the length of time that I traveled. So I'm going to go 600 times 1/12, okay? And so 600 times, or here, let me do this. I'm going to go 1/12 on my phone. It gives me that percentage times 600, okay, is 50. And so you could just also do 600 over 12, right? If we multiply these fractions together, 600 over 12 gives me 50 miles. And so that is our answer here, okay? And then another way to look at it, if we're talking about area, this would be base times height, 1/2 of that. Oh shoot, did I do something wrong here? Hang on 1 second. Oh yeah, so this is a triangle. So this 50 miles isn't our answer. Our area answer is actually going to be this answer would be if it was this box, but it's not. Okay, so this is a triangle, and so we were accelerating at a constant rate. So actually, our area would be 1/2 our base times height. So this was our height, this was our base, and it would be 1/2 that. Okay, so we did base times height. Now we need to multiply this, or we need to multiply this by 1/2, which would give us 25 miles traveled. Okay, and that would be the answer for B. That would be how far we travel in the first 5 minutes. And I know that was a little confusing. Sorry about that. If you have questions, seriously ask me. I do think that this is a good thing for you to see. I hope that wasn't too confusing. If it was, go back, watch it again, maybe slow it down, work through it. Basically, all I'm doing is canceling out units here. And then here, my little goof up was that I was just doing it like assuming that we were traveling the same distance the whole 5 minutes, or the whole 1/12 of an hour, but this is a right triangle, so we do need to do our area as if it had this 1/2 here, which would change our answer from 50 to 25. Okay, so now we're on A, how far would it travel in 25 minutes? So now that I know how far I traveled in the first 5 minutes, I know that I traveled 25 miles here. Okay, I can just do the calculation of 600 times the last 20 minutes. Now again, I need to convert these 20 minutes into hours. 20 is a little bit easier. So 20 minutes is 1/3 of an hour, because 20 divided by 60 is 1/3. So 20 minutes equals 1/3 of an hour. And again, you could do this conversion like this. Again, I only did it because I didn't know right off the bat how many hours 5 minutes was. But now, looking at this, 1/12 does make sense, right? There's 12 parts of the clock, and they each are 5 minutes. Anyway, so 20 minutes is 1/3 of an hour. So we're traveling 600 miles per hour for 1/3 of an hour. So this one, because it is a rectangle, we can just go ahead and multiply 600 by 1/3, which gives us 200 miles during this time. Okay, and that is our rectangle. So then in 25 minutes, that's the entire shape. So if this is just the rectangle part, we need to add the 25 miles from down here plus the 25 from below. Means we get 225 miles, okay? And that is not a 5, that is a 5. Perfect, okay? So 225 miles. So for part A, how far did we travel in 25 minutes? 225 miles would be our final answer. And in the first 5 minutes, it would just be 25 miles, okay? So now, 11, consider the ascent of a passenger jet. A, draw a velocity time graph to model the ascent of a passenger jet using the information given. The jet took 7 minutes to reach a top speed of 600 miles per hour. The jet continued to travel a constant speed of 600 miles an hour. The jet left the airport 4 hours ago. Okay, so then it says draw this. So I'm going to go ahead and draw this. Okay, and I'm going to do this a little kind of maybe wonky. So 1, 2, 3, 4, 5, 6, 7, and then maybe get a couple other ones. So this is 7, and I'm going to say that these are in minutes here at the bottom. Okay, and then this is going to be 600 miles per hour. So if I were to draw this, my point where these cross is going to be right there. So at a constant rate, that's it accelerating. That's this first part. It took 7 minutes to reach a top speed of 600 miles per hour, and then it traveled that far. It left 4 hours ago. So it took 4 hours, or it's been flying for 4 hours. So it would be constant for all the way up until, okay, and I'm not going to draw it all the way out here to 240 minutes, because 4 hours is 240 minutes. But you can imagine, because it's flying at a constant speed, we can just like skip some in here, right? I don't know if that freaks you guys out or not, but then this would go to 240. So we would have a big long rectangle, and then a big long rectangle from 7 minutes to 240 minutes, okay? So then the question B says how many miles has the jet traveled? So we're going to do the same exact thing we just did above, okay? Only this time for the first 7 minutes, this part, okay, we're going to have to go 600 miles an hour times, and we need to find out how many hours 7 minutes is. This one's a little more tricky, okay? So I'm going to do that crazy thing again. Times 1/60 hours a minute. Okay, and so because the 7 doesn't fit nicely into 60, that means, so our minutes are still going to cancel. So that means I'm going to have 7/60ths of an hour. And so this one's gross, But that's why this is kind of nice to see for problems like this where it doesn't go perfectly in. So now I'm traveling 600 miles an hour for 7/60ths of an hour. So I'm going to go 7/60ths, get a fraction. I'm doing this on my phone off on the side. Then I'll multiply that by 600. So in this time, okay, and remember we are doing the area of this triangle, so I need the, so area of a triangle is 1/2 base times height, okay, and my base is 7/60ths, so I'm just going to rewrite this. I'm going to say that my area of this, under this curve, is 1/2 times 7/60 times 600, okay? And then over here on my calculator, doing all this, I already did part of the work. So that divided by 2, okay, so I got my answer, it was 70, that was this, but now remember I have to divide it by 2 because we're doing the area of a triangle. So 70 divided by 2 is 35 miles, okay? And so another thing to be aware of, okay, another way you could do this is you can go 7/120 and then multiply that by 600. You'd get the same answer, and I'll just go ahead and do it over here on my calculator as well. And sure enough, okay, 35. So there you go. So 35 miles in the first 7 minutes. And then for the rest of the time, okay, so if 7 minutes is 7/60ths of an hour, okay, I still have 240 minus 7, so 233 minutes that I need to travel at 600 miles an hour. So there's a couple ways you could do this. The way that I'm just going to do it, okay, so if 4 hours is 240 minutes, that means that 240 over 60 is the number of minutes, or the number of hours, okay, because 4 hours is the same as 240, so 240 divided by 60 is 4. So this is how many hours they traveled total, but I just took away 7 for the first 7 minutes, so what's left over is 233 over 60, and this is hours, okay? And so because the rest of the shape is just a big long rectangle, okay, I can just multiply the height by the base times the height. So the base is this minutes, which is this 233/60ths, and then the height is still going to be 600. So for this part, I can go 600 times 233 over 60. Okay, and I'm going to do that over here on my phone. And actually, I'll just go ahead and plop it down right here. So 233, okay, 233 divided by 60. I get this gross decimal here, but I still need to multiply it by 600. Gives me 2,330 miles, okay? And I can't tell if I'm off the screen, but there we go, okay? And so, now, this was in the first 7 minutes, 35 miles. This was in the rest of the 4 hours. So now I just need to add those together, and I'll get 2,365 miles traveled, okay? And again, we're just doing this using area, okay? So I took these two, combined them right there, okay? But this is my final answer. And so we're just using area to calculate this. And actually, if you guys ever get into calculus, you'll do some of this as well, finding the area under a curve to give distance traveled and things like that. So there you go, a sneak peek at calculus for those of you that might end up there. And then I believe that's all of 5.4. Yeah, it is. So yeah, I hope you guys have a wonderful day. I'll see you in class. Adios.